Hello, welcome back. Today, ladies and gentlemen, we will talk about this topic called periodic trends. Periodic trends are patterns on the periodic table, repeated patterns. Remember, the word periodic means there's a repeated pattern, and there's a couple things that are repeated. Reactivity, things like that. And so a couple of trends that we're going to talk about here is atomic radius, ionization energy, electronegativity. It's very closely to electron affinity, although not exactly the same, but we'll use the same thing. We'll assume for our purposes, we'll just say that they are the same thing for our purposes, okay? But be aware they are not exactly the same thing. Metallic and non-metallic character. As you covered the periodic table last week, you should remember now that metals are on the left side of the periodic table. Your metals are on this side. And then your non-metals are on the right side. Yeah, your non-metals on the right side. So as we go downward, they become more metallic character. Metallic character meaning what? Meaning they are more, they have stronger, higher properties. Or I don't know how you measure strong or higher, but properties that are more, can't find the right word right now, but they're more metallic. Let's just say they're shinier. They are more conductive. They have more electrons in their electron sea. So we'll learn about more metallic bonding later on. But our focus is on three trends. Our focus is going to be on radius, ionization energy, and electronegativity. So before we learn about trends, we need to get some vocabulary down here. So the first one is effective nuclear charge. Effective nuclear charge is the pull, the attraction of the proton, the positive nucleus, to the electrons that's keeping it, that's floating around in the electron cloud. It's not pulling it into the nucleus, but there's attraction to it. Just like planets around the sun, right? The sun is our center, and it's keeping us in orbit, but it doesn't pull us to crash into the sun. So that is a nuclear effective charge. The more protons it has, the stronger the pull, the attraction is going to be. And the shielding, the word shielding, now you have electrons, you have different energy levels. So the inner electrons, you have electrons on the outer shell, and then you have the inner rings. It's going to shield. The word shield means it's going to block, to slow down, or to decrease the attraction. So here it's going to block the attraction from the nucleus. So the ones outside are not as attracted. So they're loosely attracted, so the ones outside, and that's the effect of shielding. So the more energy levels you have, the higher the shielding is. Okay. Electron repulsion pair. So you can pretty much read that and understand that due to like charges, electrons repel each other because negative repel, like charges repel, opposite charges attract. Okay. And so the first trend that we're going to talk about is radius. This handout here tells you very, very wordy definition. I'll try to make it as simple as we can to help you understand. So you have the notes page. Let me pull up the notes page here. Alright, first of all, the definition here. So the radius in math is basically from the center of the circle to the edge, right? So the radius definition from the handout earlier just basically said from the nucleus to the outer edge of the electron cloud. But as you know, the atom is the cloud. We really don't know where it ends, right? There's a cloud. It's a cloud, so we don't know where it ends. So another definition from another textbook is that it is half the distance between two nuclei. Half the distance. So basically, we take two circles or two atoms, two bonded nuclei. Okay, they have to be bonded, or else nuclei. So half the distance. So basically, it is, in the end, essentially, it is kind of the same as the arithmetic or the math radius. So it's from the middle, half the distance would give you the radius. All right. The trend, as you saw earlier, as we go down, it actually increase in size. Increase in size. And you can kind of draw it like a snowman. Okay, just keep this and think of this as size equals snowman. Snowman. S and S. Right? Size and snowman. Alright. And why is it snowman? Because as we go down, it increases. And then when the snowman falls over, you think about, oh yeah, over time the snowman falls over, and so left to right, it's going to decrease in size. So trend top to bottom, it is going to increase in size, increase in radius, increase radii. Going top to bottom. Radii is plural for radius. Left to right, it's going to decrease. The trend is what is happening. Left to right, decrease in radii. Sorry, I'm writing with a finger on my iPad here, so it gets a little messy. Okay, the reason. Top to bottom is fairly easy. As we go down each row, we're adding more energy levels. We're adding more rings. We're adding what energy levels is more and more accurate. But we'll use rings interchangeably to help us understand a little better. So as we go down, we add more rings. One ring is going to be smaller than two rings. Two rings is going to be smaller than three rings. So as we go down, added energy level. Added energy level. So you can put it in like rings in parentheses to help you remember. Rings, so the size increase, right? I'm not going to write that part. So we add energy levels, so the size increase. Right? You can write that. I'm not going to write that. Left to right. What happens left to right is that we add, so the nucleus, we add more added protons. So as we go over left to right, remember from carbon, nitrogen, oxygen. Carbon has 6 protons. Nitrogen has 7, oxygen has 8. So we're adding more protons. Okay? It's going to increase added protons. Increase. I forgot what the word was. Effective nuclear charge. I think effective nuclear charge. We just mentioned it earlier. So the nucleus is pulling the electrons a little stronger. Increase effective nuclear charge. Pulling electrons closer, slightly closer. Not too much, slightly closer, making it smaller. So as we go left to right, we're adding more protons. So carbon is going to be slightly bigger than here's carbon. It's going to be slightly bigger than nitrogen, and it's going to be slightly bigger than oxygen. Slightly, okay? My picture is clearly showing that, but slightly. So we go left to right. Increase protons, added protons, increase effective charge, pulling electrons closer. And so you can see that on the infographics earlier, right here. Across a period, effective nuclear charge increases, right? Causes greater attraction to electrons, pulling electron cloud closer to the nucleus. So all that whole paragraph there can be summarized in what I just said earlier. Down a group, the number of energy level increases, so more energy levels, therefore higher. Bigger the atom is. All right, and so what kind of questions do we have? So we have these things. Hold on. You pull up a periodic table. So you need a handy dandy little periodic table. So make sure you have one of those. I'm trying to pull mine up here. Alright, so now we have that there. So you flip back and forth between this. So we have these three elements, F, K, and Br. F, K, and Br. F. So find F, K, and Br. So you put in order. Is which one's the smallest, right? So when we talk about the smallest atom, look at the rows. 1, 2, 3, 4, 5, 6. So row 2 only got 2 rings. So F is clearly the smallest atom. So F is first. So F is first. And the second one. Now these two, K and Br, they're on the same row. But remember, what is our trend? Our trend is to the right. To the right is smaller. So Br is going to be smaller than K. So K on the left is bigger. So on the same row, remember snowman. Top going down is bigger, but left to right it gets smaller. Left to right. Okay? It gets smaller left to right. So further right is going to be smaller. So you always ask yourself first, which one's lower? Okay? So the lower one is bigger. So which one's higher? The higher one, the one above, is going to be smaller. So number 2 here. So we put that in number 1. Number 2. No, I'm sorry. B. OS NIFE. OS NIFE. OS NIFE. Let me. OS NIFE. OS NI and FE. So we have a couple cases here. So now the first one. So clearly OS is the biggest one because it has six energy levels. So OS is the last, right? So now we got to decide which of these two, FE or NI, which one's smaller. So to the right is smaller. So NI is the smallest, and then FE, and then OS is way down. So it's going to be the biggest atom right there. So it's just practice, so you get familiar with which one's bigger, which one's smaller. Okay, so that is the first trend. That's the radius trend. You'll go ahead and finish these couple of questions here. Couple of questions there. So right now, number 2 here, 2CLBRGA, for example, it's asking for decreasing. So now we're going to put them in order from greatest to smallest, from biggest to smallest. It's the same concept, it's just reversed. Okay, I forgot the elements. Let's go back real quick here. CLBRGA. CLBRGA. CLBR and GA. So, which one is the biggest atom? The biggest atom is going to be lower. So these two, one of these two is going to be the biggest. And now they're on the same row. GA and BR. The one to the right, remember the snowman, falls over, you get smaller and smaller, left to right. So GA is on the left, so GA is the smallest. And then BR is on the right of that, and CL is above, so above is always going to be smaller than below. Alright, so that's the order from biggest to smallest. So be able to do both ways, okay? Be able to do both ways so that no matter how they ask it on a quiz or a test, you can handle both situations. So practice that. That is the trend for radius. I'll make the next 2 videos, the next video on ionization and electronegativity. As long as you understand radius, the other 2 trends are going to be a lot easier. And the thing is, you must understand the trend for radius in order for you to understand the other 2 trends.